the edge of a universe humming a tune.
Hey guys, this is ChE 321, first part of the lab. So as always in lab, you want to start off safety is first. So as you can see, my lab members are putting on their lab coats, okay? Yeah, get into it.
Glasses.
And the glasses. It's always important to put on the proper PPE. So that means lab coat, hair is up if you have long hair, as well as putting on the glasses. And if you're entering any lab that has a hazard for pipes or anything where you can hit your head, it's very good to put on a hard hat. So we'll be back to discuss more in the next lab. Okay guys, we forgot to mention gloves. Gloves are very important for each lab.
Listen to this track.
For our first experiment, we had the most trouble with doing just the density calculations. So the best way to do it is to get the scale and then put your beaker in it, and then you want to zero it with the beaker in there, so then you're at 0. And then you use the pipette to take any volume of the oil that you choose. It doesn't matter. But the most important part is that it measures to the tenths place. So you want to record on your data sheet to the hundredths place for data measurement. And then you get the volume, record that, and then you just pour this into here. And then record the mass from the scale. And that's the best way to do it. Oh no!
So when measuring your yarn, you won't need this small one. So I would ask for the bigger meter stick, so you'd have an accurate measurement and more consistent measurement of each yarn, as well as the length of the yarn needs to be long, and then there should be more yarn and then less solution, so it'd be absorbing more.
One with the UV is measuring the baseline solution. What you're going to do is, this is your blank solution. Wipe down sides to be red. Place it in there. And then you're going to close this and then run your measurement. And then when you're measuring the concentrations during the experiment, you're going to have 4 different temperatures. If you run all 4 temperatures at once and try to stagger it, you're going to get some backup because this machine runs slower than you expect. So we recommend just doing 2 temperatures at a time and staggering those 2. And so, same process, you're just going to wipe it down, make sure it's clear. And then you can run 2 at a time because this is just 1 and 2. And then I believe that is it for lab 2.
So looking at what's behind me, please do not be intimidated, okay? So in this lab, it is very important to read labels. For one, measuring the flow rate, it tells you where the proper equipment is to hook up the system so you're able to run through your experiment. As well as it's also good to always have DI water filled up, because in this experiment you do use a lot of water, as well as going back to labeling and reading being very important. As you can see, this is labeled as 1, 2, and 3, but when you go up here, it's labeled 3, 2, and 1. So please read. Thank you.
Go.
So we're back.
So when you're making the stock solution on this one, we filled up each of these CSTRs, and it was about 2.5 liters per trial, and we ran 3 trials, but in our proposal we only made 4 liters of stock solution. So make sure you make enough stock solution for all of your trials, so you don't have to remake it, which would mess up your calibration and stuff. Also, in the lab, when it says remove the water by siphon, this is a siphon. You put it in the tank, and then you put the other side in the tube, and you just pump it, and it brings the water out.
You thought it was over. Ha! You didn't have to cut me off like that. We was nothing.
Look at this, y'all. Look at this.
There's no half here.
Oh.
Got him! Got him!
Okay, guys. So we're back. Hard hats are on. We're entering. Just look. Just wait till the door opens. All right. You see the sign here? Proper PPE. Hey guys, so we're back again in the lab. Hard hats are on, as the door stated. So this lab is very team oriented. As you can see, I have my team members in the back. Where y'all at? So also, I don't know what he's doing, but this is not very, it's not giving team spirit. So if you could, thank you. And now we're gonna go.
I know you'll peeped him shaking his head.
And now we're gonna go over to Kylie Mae to talk about not flooding the lab.
So first things first, take this off the drain, and then you're gonna have the water running constantly. So you want the water to run into here instead of a bucket. We tried the bucket first, and it started overflowing, and we had to constantly pour it out. And then communication is key to this. So each person has a role. So his role is to switch the valves. Then he tells us when the valves are switched, but then she reads the pressure.
Zoom in.
But then Jordan's the one that's recording. And then I am the one.
I was recording that.
Yep. And then I am the one that puts it in here, but I have to tell Quinn when to start the timer, which is when I put the hose into the graduated cell.
Also, too, when measuring, did we say that? When measuring, make sure you're on an even surface. So you can use this instead of being on the ground to come here and measure, but make sure, it wobbles a little bit, but make sure it's even and steady throughout your whole measurements.
Zoom in on the stuff when I point it down.
Yeah.
Alright, or did you start it?
Yes.
Is it going? Alright, when you're working with the piping system, it might look a little daunting, but it's actually very simple to use. So this hose will already be on, and you just want to keep that hose on the entire lap. And then over here is your exit hose. You also can just keep that valve completely open for the entire lap. So you don't want to touch either of those once you start. So you want to control everything with these type of valves. And it's very simple. When it's 90 degrees, it means your pipe is closed. And when it goes in line with the valve, it means it's open. So you can control all the valves with each one. So when you want to open the water, you would open this valve, and then you would want the rest of them closed. And then you would open just one to measure each type of pipe. And it's also important that you have somebody who can identify which type of valve each of these are. So I don't remember off the top of my head.
Tip, I think this one, you can look up the company and the valve type, and it will actually give you what type of valve that is.
Okay, so for lab 5, there's a lot of variables you can choose from. One of them will be material, so you could do different material in the same size. There's bigger and smaller balls, so you can do different sizes, and then you also have this for convection to help cool it down faster. I would recommend not trying all 3, you will run out of time. I would also recommend doing smaller balls because they cool down quicker. And finding the radius and diameter of this, you could do a bunch of ways to measure it. I would not recommend using a ruler. You would either find, we can't find it right now, but there's a clamp somewhere and it measures it for you. Or you could fill this with a known volume and then add the sphere inside and find the change in volume, and that'll be how big the ball is, and then you use the equation for the volume of a sphere to find what the diameter or radius is. And then also, this is what measures the temperature of the core, and there's a little hole inside each sphere, and you want to make sure that wire gets as far down in there as you can, as close to the middle.
We've given you tips on how to be successful in the lab. So now here are some words of wisdom for being successful outside the lab too.
Okay, proposal meetings. It is very important that you meet your TA before the meeting, so that way you understand everything that's going on in the lab. Also just making sure that you're on the same page for procedure and your variables. That is also important.
I think going to the lab before helps you prepare for the lab. I would say go before, like 2 days before at least.
And two, I'd also add in, it's also good to talk with your team members to know which chemie classes some of y'all have taken, as these labs go across fluids, heat transfer,
Reactor.
so it's really good to talk with your teammates. Yeah, also too guys, good tip, make friends with the other lab groups. You see them putting on the proper PPE, okay?
Otherwise,
Congrats on making it to the end of this video. When cleaning up, just make sure you put everything away where you found it. Make sure if you flood the lab, that's all cleaned up, any spills, and just, yeah, put it in the correct drawers.
put the lab coats
Take
back.
off lab coats.
Make sure you take your gloves off before you leave the lab room. Good job, guys. Bye.